Have you ever just stopped and wondered about all the invisible pushes and pulls that are happening all around us all the time? I mean, from a ball falling to the ground to a bike speeding down a hill, our entire world is constantly in motion because of these things we call forces. So let's dive in and explore the fundamental rules that shape our universe every single day. So really get our heads around this, we're going to start with a story. A simple, everyday bike ride that, believe it or not, turns into this fantastic little journey through the world of physics. It's going to show us all the forces that were at play in every single moment.
So meet Sonali and Ragini. As they're riding their bikes, they can feel the wind pushing hard against them, right? Making them pedal even harder. Then they notice that the rough patches on the road are kind of slowing them down. But then, as they start going down a hill, they stop pedaling, but they just keep getting faster and faster. They feel this mysterious pull, and that's when Sonali shouts out the big question. What could possibly be pulling them?
And that question Sonali shouted, that is exactly what we're here to answer. But before we can understand that mysterious pull on their bikes, we have to start with the absolute basic building block of it all. So, what exactly is a force? Believe it or not, it's actually that simple. In science, a force is just a push or a pull. That's it. The wind pushed against the girls, and something pulled them down the hill. It's all about an interaction between at least two objects. So, what can these pushes and pulls actually do? Well, a force can get something moving from a complete standstill, like kicking a football. It can change how fast something is already moving, like if your friend grabs your bike to slow you down. It can change its direction, like when a cricket bat hits a ball and sends it flying somewhere else. And yeah, it can even change an object's shape, like when you squeeze a balloon. And this shows the two sides of that coin perfectly. On the left, you've got the fielder applying a push with his hands to stop the ball's motion. And on the right, you see a hand using a pull to open up a drawer. Both are perfect everyday examples of force in action. Oh, and just a quick little side note, but it's important so we're all speaking the same science language. Force is measured in a unit called the newton. We just write it as a capital N. Think of it like how we use meters for distance or kilograms for how heavy something is. For force, we use newtons. Now, forces basically come in two main flavors. We're going to start with the first one, contact forces. And it's pretty much what it sounds like. These are the forces that happen only when objects are physically touching each other. And if we go right back to our bike ride, we can see these perfectly. The effort that Sonali and Rajini were putting into pedal, that's muscular force, a contact force coming from their own muscles. And the reason the rough road was slowing them down? That's another huge contact force we call friction. Okay, here's a question we've all probably wondered about. You give a ball a good roll across the floor, and even though it seems like nothing is touching it, it always slows down and eventually stops. So what's going on? What's the invisible hand that's stopping it? Well, the answer is friction. And what's so cool about this slide is it shows you what's really happening on a level we can't even see. Even surfaces that feel super smooth to us, like a floor or a tabletop, are actually full of tiny microscopic bumps and grooves. When two surfaces slide past each other, these little irregularities get caught on each other, and they create a force that fights against the motion. That's what slowed the girls down on that rough road. But friction isn't always a bad guy. It's also the very thing that let their tires grip the road so they could move forward in the first place. Okay, so we've got the forces that need to touch. But what about the ones that, well, don't? This brings us to our second big category, non-contact forces. These are the amazing pushes and pulls that can actually work across empty space. A classic example is magnetic force. I mean, just look at this. These magnets are not touching at all, yet one is floating perfectly in midair above the other. That is pure magnetic force in action, a powerful push that's happening without any physical contact. It's the perfect example of a non-contact force. And here's another one you've probably tried yourself. You rub a plastic ruler on your sweater or in your hair, and suddenly it can magically pick up tiny little bits of paper. That's called electrostatic force. It's a pull between a charged object and an uncharged one, and again, it's all happening from a distance. So magnetic and electrostatic forces are super cool, right? But there is another non-contact force, a huge one that affects every single thing we do, every second of the day. And yeah, you guessed it, it's the answer to the mystery from our bike ride, that invisible pull that made their trip down the hill so thrilling. It's gravity. It's the force with which our planet, the Earth, pulls every single thing towards its center. That was the mysterious pull. It wasn't a mystery at all. It was the gravitational force of the entire planet, pulling Sonali, Ragini, and their bikes all the way down that hill. It's always there, always pulling on. You know, now that we're talking about gravity, this is the perfect time to clear something up. It's one of the most common mix-ups in science, and that's the difference between mass and weight. We use the words interchangeably all the time, but in physics, they are two totally different things. So let's break this down. Mass is simply the amount of stuff an object is made of. It's measured in kilograms, and here's the key. Your mass never changes no matter where you go in the universe. Weight, on the other hand, is the force of gravity pulling on that mass. And since it's a force, it's measured in newtons, and it can totally change depending on how strong gravity is where you are. And this table just makes the difference crystal clear. It's pretty amazing, really. Look, an object with a mass of 1 kilogram. Well, it has a mass of 1 kilogram whether it's on Earth, the Moon, or Jupiter. The amount of stuff is the same, but its weight? Whoa, it changes dramatically. On the Moon, with its weak gravity, it only weighs 1.6 newtons. But take that same object to massive Jupiter, and it weighs a whopping 25.4 newtons. Same mass, completely different weight. So let's bring all of this back together. Once you really start looking for it, you begin to realize that our entire world, every single interaction, is just a complex and beautiful dance of pushes and pulls. That bike ride was the perfect little science lab, wasn't it? Sonali and Ragini used muscular force to get going. They had to battle against the force of friction from the road and the air, and then they were sent flying by the incredible force of gravity down the hill. You've got contact forces and non-contact forces all happening in one simple afternoon. So as you're sitting there right now, just think about it. The force of gravity is pulling you down into your chair. At the same time, your chair is pushing back up on you. Friction is what's keeping you from sliding off it. Forces are literally everywhere, shaping every single moment of your life. So the only question left is, now that you know what to look for, what forces can you see at play in your world?